All six angles, all six of these are 60 degrees. Why? That's right. They equal up to 180, and all equilateral triangles are also equiangular and are therefore 60 degrees. Now, what we're going to be starting today is something that we're actually going to come back to the same DOM on in a few days. These two triangles are said to be, and here's the keyword of the day, proportional with each other. They are proportional, meaning that their two sides, their two sets of side lengths, they form ratios with one another. Those are the two pieces of vocab we're going to be talking about today in section 6.1, ratios, proportions, and the geometric mean. Ratios, proportions, and the geometric mean. Ratios, proportions, and the geometric mean. All right, first set of notes. Go faster. She's talking to me, not you. Relax. It was about to get real dramatic up in here. Okay. Now, ratios. Ratios, like the one in this triangle. When you are told the two things are proportional, that means you can set up a ratio of their pieces. For instance, the ratio of these two triangles would be 2 to 1. Now you'll see that in two different ways, 2 to 1 or as a fraction. Now I prefer the fraction way because since we have to solve these things anyway, fractions are going to be how we're going to do that. So I will pretty much always use fraction notation when I declare ratios. However, you may also see it with a colon between them. So therefore, the ratio of from one thing to another, is basically just there's two, whatever it's telling you is the ratio set up as a fraction. The only thing I guess you need to know is that one of them can't be 0. It doesn't make sense for something to be a ratio of 0. But that'll never really come into play, so I don't really know why they bother telling us that. But anyway, no part of the ratio can be 0. So it's basically a comparison of two numbers. That's really all a ratio is. I'll leave that on the board for a moment if you wish to write it. The only thing we might run into when having ratios is you may have to change your units. For instance, if I said, well, what if I use these same two triangles and I said you could form a ratio with them, except one of them was in meters and the other one was in like centimeters? Well, that wouldn't make sense. You would have to convert them to being the same units, and we are going to have a few problems like that today, where you have to convert meters to centimeters, or inches to centimeters, or yards to feet. I don't know. A lot of that kind of thing. So let's look at one of those. Well, actually, before we do that, here's one more just example. This particular rectangle. Now, there is a bonus on today's assignment, just like this problem. There's a bonus like this problem. The ratio from the length to the width of this rectangle, the ratio of the length to the width is 1 to 2. Now, would you agree that it's actually 7 to 14? 7 to 14. When they say form a ratio between two numbers, you just put the two numbers together. However, what is 7 over 14 reduced to? 1/2. You will reduce your ratios whenever you can. Once you put it in ratio form, I don't really care so much about the exact numbers. I just need the ratio to stay intact in reduced form. It'd be like me saying, actually, perfect example. You ever go to like grocery shopping with your parents and they'd be like, oh, Kool-Aid packets are 10 for $1, right? Does that mean you have to get 10 for all of them to be the same price? What does that mean each one of those packets is? 10 cents. If there's 10 for $1, then you get 1 for 10 cents. That's like reducing a ratio. 10 for $1 reduced is 1 for every 10 cents. Same thing. You can reduce every ratio, and they would be equivalent or congruent. Equivalent is the same as congruent. Okay. Simplify the ratios. Now, before we do this, I forgot to connect my board. Before we do this, let me connect my pad. Oh, God, it's not going to work. Yes, I know. Try again. Okay. I meant to have feet written in here. But let's do the first one first. Now, 81 and 3, are they the same units? Yes. And what are the units, Malik, on A? On A. Ariana, what are the units on A? Centimeters, thank you. So, simplifying the ratio, if they're both already in the same units, then you have nothing to do but simplify the fraction. Who can tell me what 81 over 3 reduces to? Very good. Now, when it comes to ratios, I know you guys have been reducing fractions for probably a few years now. But when it comes to ratios, you know how if something's over 1, they've always been like, oh, you can just go get rid of that. When it comes to ratios, you can't. You still have to leave it as over 1. Because the whole purpose of a ratio is to compare two numbers. And if you were to just cover up the 1, it wouldn't make any sense. So, 27 to 1 centimeters would be the ratio reduced. Now, let's look at part B. 9 feet, 15 yards. Are those the same? No. My rule of thumb, always change the bigger one. Always change the bigger one. What's bigger, a foot or a yard? A yard. How many feet are in a yard? 3. So, now, I will be telling you, that's not something you're going to have to know today. If there are any in your assignment that you may not know, I'll tell you. But always change the bigger. So if there's 3 feet in every yard, then how many feet is 15 yards? Multiply on your calculator. What? If there's 3 feet in 1 yard, how many feet is in 15 yards? 45. Very good. Now we've converted yards into feet. So, 9 over 45. What does that reduce to? Very good. 1 over 5 feet. 1 over 5. You just reduced the fraction, and you've reduced your ratio. Very good. Questions about how or why we did anything you see on the board? No? Good question. How many feet are in a yard? 3. So all we did was take yards and change it to feet by multiplying this by 3. It's like if you said you were 6 feet tall, how many inches would that be? So you would just take 6 and multiply by 12, right? Same principle. Same principle. Good question. Other questions? All right, let's look at another. Here's another way you might see ratios. Now, they gave you the picture here, but they won't always. The ratio of the angles of the triangle are 2 to 3 to 5. And this is how you would draw that if you weren't, if you didn't have the picture given to you. The ratio of the angles of the triangle are 2 to 3 to 5. If it ever tells you that the ratio of angles or sides or whatever on a physical object are, and then they give you a ratio, just stick an X with it every time. If it ever gives you a ratio of pieces of a physical object, just put that number in the object and stick an X on it, and you can solve it. So, what do all angles of a triangle add up to, Elon? What do all 3 of the angles add up to? Close. Madison, what do all 3 angles add up to in a triangle? 180. So, you will add these up. You'll add these up, set them equal to 180. That'd be 10x equals 180, and what is x? Very good. Then to find the actual angles, what's the only thing we would have to do? Plug it in, and I trust you can do that. Let's look at one more. What if I said that a rectangle has a rectangle has ratio of its length to width. Oh darn, I don't have a rectangle. You know what? Forget it. We're just going to say triangle. An isosceles triangle. Here we go. An isosceles triangle. Its sides have a ratio. Its sides have a ratio of 2 to 2 to 3. And its perimeter is 14. We'll call it centimeters. If the perimeter is 14 and the sides have a ratio of 2 to 2 to 3, how can I solve that? Now remember what I just said. If they give you a ratio of pieces of a physical object, what's the only thing you have to do with them? Stick an X on them. So which two sides are the same here? Well, dashes. So those are the two 2's. 2x, 2x, 3x. What is perimeter? Yeah, it's just the outside. So I would just add up the three sides, right? So these three combine to equal the perimeter. 2x plus 2x plus 3x equals 14. That's 7x equals 14. Divide, and what is x? X is 2 centimeters. Very good. If they give you a ratio of pieces of an object, just stick an X on them and put them on a picture. And then you'll always just be adding them up and setting them equal to something. That is your bonus today on today's homework, and I really hope everyone does it, because that's bonus points that go toward a test or something. That is an easy question on your homework today if you can grasp that concept. Well, I use total point system, so really it's like you throw all your points into one big bag. So basically, yeah, they go on a test. Unless, of course, you had points deducted from homework, then you could really put them in your head on whatever you wanted. But it all goes to one big total. Questions? No? All right. Next thing we're going to talk about are proportions. Proportions are when you compare two ratios. When you compare two ratios, you have a proportion. Now, except for in this class, you'll never need the means and extremes part of that definition, but you will need it for this class, so I want to write that down. Means and extremes. A proportion is the comparison of two ratios where you have two means and two extremes. And you guys use proportions all the time. You probably just may not realize it when you're doing it. For instance, if I said, what is half of 10? What would you say? That's a proportion. Because you took 1/2 of something over 10, and you found that that's something, put 5. That's a proportion. That's what you're going to be doing. If I said, we're going to be doing, that's an obvious one, because you can do it in your head, but that's all proportions are. Taking two fractions, 1/2 is the same as 5 over 10. Proportion. I'll leave that up there for just another moment, then we'll look at some examples. Actually, before we work on an example, now that one was a fairly straightforward one, 1/2 of 10. What if it was less straightforward? What if I said, what is 3/7 of 49? Well, that's much less easy, isn't it? So we're going to need to know how to solve those proportions. So the way you solve a proportion is by cross-multiplying. You solve a proportion by cross-multiplying. So this is a classic proportion. 2/3 equals 4/6. How do you see if that proportion is true? You cross multiply. Is 2 times 6 equal to 3 times 4? Yes, they're both 12. So your proportion is true. Just cross multiply and see if it's true. 2 times 6 is the same as 3 times 4. So your proportion is true. This is the important part right here. For every proportion, this is true. That's the most important thing on this slide. I just boxed it over. For every proportion, this is true. And we'll look at an example in just a moment. Sometimes it'll just give you a full proportion with 4 numbers, and all you have to do is see if it's true. And sometimes it'll give you a variable, and you have to see if it's true. So I'll tell you what, before we do those, let's just have a few. You tell me, is 3/7 the same as 21/49? How do we solve that? Cross multiply. 3 times 49 is what, somebody? Thank you. And what?
Please repeat your seniors. If your last name begins with an A, they are ready for tapping down pictures in the little theater.
And what is 7 times 21? Are they the same? So this proportion is true. What about 2/9 and 23/99? Is that the same? Try it before you say. What's 2 times 99? What's 9 times 23? Are they the same? No, this is a false proportion. Questions about how they're solving those? Cross multiplying. Okay. Always put an equal sign between them. Alright, now when you have a variable, now this is actually very similar to the one Malik just did. We can do it 2 ways. You can always use logic on these. If does 5/10 reduce? What does 5 over 10 reduce to? 1/2, right? This reduces to 1/2. This proportion is the exact same as saying, what is 1/2 of 16? 8. You could know that going into it if you know what a proportion is asking you. Now it's okay if that didn't occur to you. You could always cross multiply. 5 times 16 equals 10 times x. That's 80 equals 10x. Divide by 10, and what's x? 8. Even if you had reduced it first, you still would have gotten that. 1/2 equals x over 16. What would that be? 16 equals 2x divided by 2? 8. You can always reduce an individual ratio in a proportion if you can. Questions about this problem? Alright, let's try B. Now, that's going to be a little trickier to reduce, won't it? So, how do we solve it? Cross multiply. Now, I can tell you right now where everybody's going to go wrong with this. First of all, 1 times 3y, 3y. 2 times y plus 1, so many people are going to put 2y plus 1, which is incorrect. It's 2 times y plus 1. You have to distribute that 2. So that's actually 3y equals 2y plus 2, because it's 2 times y, and it's 2 times 1. Now how do I solve this? Subtract 2y, and you get y equals 2. And you've solved the proportion. Do not forget to distribute in these proportions. Which 2? This one? This one? Nothing, it came straight down. It's this. It's 2y minus 2y. See, this canceled, leaving you with just the 2. And then we subtracted over here. 3y minus 2y was 1y. So I subtracted it from both sides. Let's look at one more of those. How about x over 4 equals 3x over... Nope, I don't want to do it like this. X plus 6 over 12. That's not going to work. Over 16. There we go. How do I solve? Try it on your own. Try finding x on your own. And someone raise your hand when you think you've got it. Malik, what did you get? How did you get it? And what did you get when you cross multiplied? Equals. Plus. Gotcha. Very good. And what did that go to? You solved it and you didn't know it? Impressive. 24. So you subtract the 4x and you get 12x equals 24. Divide by 12 and you get 2. Very good. Let me actually draw this in. Divide by 12. Divide by 12. And you get x equals 2. Very, very good. Now there's only one thing left. Well, actually. Actually, I'm going to change today. We're going to finish the rest of this tomorrow because the other thing goes with this, but not perfectly. We've done ratios and proportions. Who remembers what the third thing was on the entry to this section? On the... Yeah. Geometric mean. Geometric mean is not hard, but it's a little different. We'll look at that tomorrow. Let's just stop with this today. But before we do, I want to look at one more type of example. Use the number line to find the ratio of the distances. So, just mean, what is the length of segment BD? BD. Easiest way to do it is just subtract the numbers. This one minus this one. 5. And what is AB? 2. The ratio of BD to AB is 5 to 2. Cameron, what is the length of BE? Very good. What is the length of CE? 6. 8 over 6. Does that reduce in any way? 8 over 6. Are they both even? If they're both even, they have to reduce. Yes, ma'am. It would be 4 thirds. 8 over 6, which would reduce to... If you do not reduce your ratio, I'm not going to be a stickler on your homework, but that will be counting off. Classic test question. Classic test question. Might say, what is the most accurate ratio for this? One option will be 8 over 6, and one option will be 4 over 3. 4 over 3 is the more accurate because it's more reduced. So, get in the habit of reducing your fractions when you've got them. I'm going to change this up a little bit. I don't want to do too much on a first day after a 3-day weekend. So we're going to come back to geometric mean tomorrow. So this is actually going to be... Actually...
Seniors, boys and girls, if your lifetime begins with a B.
There you go. That is your assignment today.
Little theater for tapping down pictures.